So there's a question that they're asking you in 3 unit to basically find the area of the ellipse, the formula of which is pi AB. So you've got a standard ellipse, center 0, 0. You've got, well, x intercepts at a and negative a, y intercepts at b and negative b. Now to get the area, you basically just use calculus. Now, you can do this in more than one way. You can do it sort of dx, you can do it dy, but let's follow the question's guidance and just do dx. So that means we sort of want to cut it this way. Now you might remember the area of some under a curve fx above the x-axis is just the integral from a to b of fx dx. So we can think of this in many ways, but we need to find let's just think of it as, okay, this ellipse is symmetrical above and below the x-axis. So let's just go work out the above and times it by 2. Okay, that would keep it a bit simpler. And we could even simplify it further. The right-hand side and the left-hand side are symmetrical. So we could literally just focus on 1/4, just that quarter. So the area of the ellipse is equal to 4 times the upper quadrant area. Now the upper quadrant area is just going to equal the integral. Well, you're going to go from if we're doing dx, you're going to go from the smallest, which is 0, to a, of fx, which we'll need to work out, dx. So at this point in time, we need to work out what fx is, but we've got it as 4 times the integral from 0 to a of fx dx. Now, fx is basically y. So because we know x squared over a squared plus y squared over b squared equals 1, we can then solve for y. So y squared over b squared equals 1 minus x squared over a squared, which for simplicity I'll write as 1 over a squared minus x squared. So y squared must be equal b squared over a squared minus x squared. Now, this is not a volume, this is an area. So you have to get the y, which means you have to take the square root. But of course, there's a positive and there's a negative. Now keep in mind that a and b are positive values, and the square root is always positive. And you are going for the top one, or at least I am going for the top one, the way we're doing it, because we're doing the upper quadrant. So that means the y values are positive. So just in case there's any confusion, y equals positive b over a squared minus x squared represents sort of this branch of the ellipse. And y equals negative b over a squared over a squared minus x squared represents this branch of the ellipse. And the reason why I get 2 answers is because for any particular x value, there indeed are 2 values of x, except for at the extremes of a and negative a. So therefore, the one I'm looking for is the red one. So that means my area is going to equal 4 times, or the integral of 0 to a of b over a squared of a squared minus x squared, which, well, you can just take out the constants. And that's the intermediate step they wanted you to get. Not the only way to do it, but certainly a valid way to do it. Once we've got there, we just need to now actually integrate it to get the answer of pi AB. Now the question does give you a hint, but you may want to think about how you would do that, just as a bit of a challenge. So we've now shown the area is 4b over a, the integral from 0 to a of the square root of a squared minus x squared dx. If you see this sort of situation of a squared minus x squared, the simplest way to do this is doing it a different way. So you might think about what that is. Well, the question forces us to do it the complex way. By request, it asks us to sub x equals a sine theta. So we will do that. You don't need to Okay, but let us follow the question's request. Now, if x equals a sine theta, as with any substitution, you're going to have to change the limits. So when x equals 0, that means a sine theta equals 0, which means, of course, sine theta equals 0, which of course means theta equals 0. When x equals a, very similarly, you should get theta equals pi over 2. I'll leave you to do the bits in between there. Now, you also have to change the dx. So you just differentiate it. Dx d theta, you're differentiating a sine theta. It's going to be a cosine theta. So the dx would equal a cosine theta d theta. That means, because we've worked everything out, when x is 0, theta is 0. When x is a, theta is pi over 2. You have the square root of a squared minus x squared, which is, well, a squared sine squared theta. And dx is, well, a cos theta d theta. So we're going to have 4b over a. I'm going to take the red a out because it's a constant. We're going to have the integral from 0 to pi over 2, the square root of a squared 1 minus sine squared theta times cos theta d theta. Now we should recognize, of course, that the a cancels. That gives us 4b on the outside for the moment. 0 to pi over 2. The square root of a squared is absolute value of a, which is positive anyway. Now 1 minus sine squared is cos squared. Now the square root of cos squared formally is the absolute value of cosine. Because remember, the square root of x squared is not x, but rather the square root of x squared is the absolute value of x. And basically it comes down to the fact that when you square root something, it's got to be positive. The square root of 25 is 5, not negative 5. So if I took negative 5 and squared it, if x was negative 5, x squared, negative 5 all squared is 25, the square root of 25 is 5. It's no longer itself, right? Only. So therefore, negative 5 all squared square root is 5. So it's an absolute value of negative 5, which is 5. That's a detail that is true, but often you can get away with if you don't pay attention to it. Sometimes you can't. And in this case, you could get away with it. I don't think you'd lose a mark. And the reason you can get away with it is because your theta is from 0 to pi over 2. That's what that limit means. The limit is referring to the values of theta. It's in the quadrant 1. It's a cosine, which is always positive. So therefore, we can now take out the a. So it's 4ab. The integral from 0 to pi over 2 of cos squared theta d theta. You should know how to integrate cos squared. That's just going to be using your half 1 plus cos 2 theta, double angle formula. And then you can now integrate. If you put in pi over 2, you get pi over 2 plus, well, basically 0 minus pi over 2 and 0. Must have made a mistake somewhere. One, two. Oh, the mistake is right here. So I sub pi over 2, it's pi over 2 plus 0 minus, I'm subbing in 0 now. So it's minus 0. I'm subbing in the wrong part there. So it's minus 0 minus 0, which means it's 2ab times pi over 2, which is pi ab, as required. The mistake was at the very end. So that's how we do it their way, using trig substitution. And it can be done. And you have to do what they ask you to do. However, if you are given a choice, I really would not have recommended you do the question that way. You know that you are trying to work this out. Now, it might pay to consider what that represents. This represents the area under the curve y equals the square root of a squared minus x squared from x equals 0 to x equals a. And you might want to think about what this is. Because if y equals the square root of a squared minus x squared, you hopefully can recognize, or if not, let's see what happens when we square root. And then move things to the other side. This is really just the area of a circle, or part of a circle. It has radius a. So you're really just asking, what is the area under the semicircle from 0 to a, which really is just this area. And that is quite clear. It's a quadrant. So it's 1/4 of pi r squared. So it's 1/4 pi a squared. Which means, assuming you're allowed to do it that way, you could have easily just said a equals 4b over a times 1/4 pi a squared, because area of a quadrant, giving you an answer of pi ab as required. And if you compare the amount of work required for this versus the amount of work required here, it should be quite clear which one is faster and less error prone.
Yeah.
You are sometimes forced to do questions the hard way, as is the case here. But that's how you do it. Okay. Let's look at the next one. So the derivative of